This is CPE 133. This is experiment 9. What we're going to do in this experiment is modify our 4-bit up-down counter from the previous experiment and give it a couple extra features and give you more experience doing some awfully fun stuff. So the objectives are to understand 7-segment display multiplexing, because what you have to do in this experiment is design your own display multiplexer. Not a big deal, very straightforward, gives the opportunity to put some really interesting, we'll say circuits, really interesting modules into your circuits. The second item here, we're going to change one of the outputs, which is Stone Age unary output, and we're going to change it into a Mealy type output. Previously it was a Moore type output. So once again, we're extending experiment 8. We are taking out the previous display multiplexer and adding our own, and additionally we're making that Stone Age unary output. We're changing that from a Moore type output to a Mealy type output. Good news, we're able to visually verify the proper operation of this experiment. We don't need to simulate it. So this is our 7-segment display device that we have on the Basis 3 board. We have what we call 4 7-segment displays. They are actually 8 segments because we have this what we call a decimal point sitting there, not necessarily a decimal point, more like a radix point. But this is our display. So what we see here is one circuit. I'm going to go ahead and erase this. A circuit of one of these displays. So this is essentially, these circuits are going to be equivalent. Probably red is not the greatest color. So this is what you're seeing here. This circuit, there's actually 4 of them on this board. So of course that means all the segments are shorted together, so you can't just directly drive one segment. You have to, when I turn the A segment on, it turns on all 4 A segments if the anodes are turned on. So 2 things need to happen for a display to light up. You need to turn some segments on, and you need to turn the anode on. So this is roughly the circuit here. It's beyond the scope of this class, but what you'll get from looking at this circuit is both the anodes and the segments are active low. So essentially, to turn them on, you need to send them a 0. Keep that in mind. Everyone forgets that. So there's 4 of these displays, and here they are coming up next. What we're going to do to multiplex the displays is turn one on. Remember, it's active low. Wait a while. Turn the other one on. Wait a while. Turn the other one on, and turn the other one on. And we do this cyclically. Back here, it goes to digit 0 again, etc., etc. We do that really fast. That means at no time is more than one display actually turned on, but your eyes don't see it due to retinal persistence. It looks like there's multiple numbers on the display. And so these are, once again, these are the 4 digits sitting there. You're turning one on, then the next, and the next, and the next. For this experiment, you're only using 2 digits, so it really simplifies the design of the display multiplexer. So once again, probably a good start on a piece of paper with this experiment. By all means, don't do it from scratch. Start with experiment 8. The first thing I would do is change out the Moore type outputs for the Stone Age unary count and make them a Mealy type output. The second thing I would do is take that display multiplexer out, which was the module we provided for the previous experiment, and design your own display multiplexer. Keep in mind, it's only a 2-digit display multiplexer. And by all means, check the lab manual out for other interesting details.